Hi and welcome to part 7 of the Kicad tutorial. So in this tutorial we are going to create some footprints, create some custom footprints for the PCB. Now I did think of something. Remember last time I was talking about the footprint library, and I was trying to find where the footprint library table was for this project. Well, I found it. It is actually in our Christmas bauble directory. And you can see that there is just one library listed here, like this. C-bauble footprints.pretty, which is the one that we created. And if we actually have a look in the Christmas bauble directory, what you can see is that's our footprint library. That's our schematic library. That's the PCB layout. That's the net list, that's the schematic, that's the overall project. There's our footprint library table that we just looked at. This is the file that associates footprints, schematic elements with footprints. Now that's also stored, can be stored in the net list as well. So you can backport back. I'll show you. If you load up the schematic, there's a button here, back import component footprint fields via CV/PCB comp file. So what happens is if you edit, because you can change the footprints directly on PCB new, that will change the comp file, but you can actually then back import them into the schematic. Yeah, okay. So, right, let's get back to our schematic then. And where we left off was we just laid out most of the things, and now there's mostly ground left. But before we go and finish off laying out the ground, I'm just going to turn off the rat's nest. It's actually called a rat's nest, I didn't just make that up. And then we've got these switches. So we need to make, what we're going to do is make footprints for those switches. I'm just going to put them somewhere sensible. I can't actually remember where they connect up. Where does this one connect up? Oh yeah, it connects to there. Wait a minute. Yeah, that's VCC. So this is the one that's pulled up, and then it needs to connect to there. Right, okay, fair enough. And then the other switch is pulled down to ground. Okay, yeah, and it connects to here. Well, they actually both connect to the AC. So this, for example, if you actually look at that, if we follow that trace around, they both connect to there, because that's the output of the XOR, but it's also the serial input pin 14. So we want those switches so that when we press the pull down switch, it actually pulls the serial input down to ground, and when we push the pull up switch, it actually pulls the serial up connection up to VCC. So let's just put them, we'll probably put them there, there's quite a lot of space there, but we need to create the actual footprints for them. So how should we create the footprints? Well, first of all, we need to know what the footprint looks like. Now, if I go onto eBay and search for push switch, right. So this is the type of switch I'm going to use, momentary tactile switch. And what we want to actually do is we want to find a schematic. I mean, they look good, those switches, you know, we could use any of those, that tall one for example. The thing is, we need a, you know, that isn't really good enough. I don't necessarily trust that. I mean, maybe it's good enough, but what we really want is a proper schematic, a proper footprint. So what about this one? Okay, here we go. So if we bought a switch, one of these switches, we can actually see the dimensions here. So that's quite useful. It doesn't tell it what it doesn't tell us. I'm just looking at this. It doesn't tell us what how big these pins are. Now normally, if we went on to something like Farnell, I'll just do this so we can have a look. And look for a tactile switch. Let's have a look. Tactile switch. Tactile switches. There's a hell of a lot of them. Yeah, Farnell's quite good if you want to. I mean, Farnell or DigiKey, they sell so many components. I mean, really insane amounts, that you usually have to use this filtering system to actually see what it is you want and to narrow down what you want, because you know there's 1,000 tactile switches for sale on there. Okay, well, here we go. Cool. So this tactile switch, let's put that on there, for example. These are 11 pence each. And the cool thing about Farnell is there'll be a technical data sheet here. So if I click on that, then we can actually see what this thing is. You know, and it says it can handle 50 milliamps at 12 volt DC. You know, that's enough. We don't need a lot of current at all. And then if you look at here, we'll see that now we're talking really precise specifications, which is really handy. So we're going to use that specification as a way to create our footprint. So what I'm going to do is I'm just going to, again, as we did before, put that up in the corner so I can see what's going on when we're creating it. There we go, that'll do. So I'm just going to make that always on top. Right, now go back to PCB new a second. So we want to create a new footprint, so I'm going to open up the footprint editor. Now, because you might just be watching this tutorial to just to create a footprint, just to learn how to create a footprint, what I'm going to do is I'm actually going to create a new active library. And when I did this earlier in the tutorial, I kind of made a bit of a mess up, so let's just do it all again as if we didn't have a library, just in case you got confused in the last bit anyway. So you always have to have an active library selected before you can load a footprint or create a footprint. But what it turns out you can do, if we create a new footprint first of all, and we call this our tactile shallow, for example, switch. Now, if I'm just going to move a couple of things about. It's just habit, really. Now, what we need to do is we need an active library before we can save that. If we then do save footprint in new library, we've already got C footprints pretty, but let's create another one and we'll call this switch footprints. Oh yeah, it has to be a .pretty directory. Now, believe it or not, that is actually saved, although it doesn't really seem like it is. Now we should be able to go to set active library and look up switch footprints. Okay, good, and it's not there. Now the reason it's not there is because we haven't added this to the library table. Now if we go back, remember the I was talking about the fp-lib-table. We've only got C bauble footprints. So there's a couple of ways I can now add that to the library table, otherwise we can't actually set an active library. I can go back to PCB new and I can go to preferences library tables, project specific libraries, and add it in there, or you can actually just edit that file. I've not actually tried this while it's running, but let's try it. So just let me get rid of that a second. So all I'm going to do is just copy this line, and we know that it was called, hang on, sorry, just let me exit that. You can see it's actually there, switch footprints.pretty. It did actually create the directory, and it has actually created that shallow switch Kicad mod footprint file. So we know it's actually done that, even though looking at this, there's no active library, you can't really tell. So again, let's edit the fp-lib-table, and oh, I can't remember what it was called. Switch underscore footprints. Right, now that is added in. Now I do wonder, I'm curious, does that immediately add it in? Maybe not. Is it available in here? No, it's not. So that's probably if you just directly add it in there, it doesn't update it. That's okay. So what we'll do is we'll just quit and see if it's then there when we come out. Yeah. Okay. Yeah. Fine. That's fine. Exit without save. It's going to completely exit Kicad. I just want to see if this actually does it. Go back into the footprint editor. Let's have a look in the library tables. Cbauble is a duplicate footprint library. Now, it's good that this error came up. I mean, obviously we know there's something wrong here. And if I look at that, maybe that's why it didn't come up. It's true, we've given it the same name. It should be footprints, switch footprints. Push switch, tactile, let's call it tactile switch footprints. We can't have it the same name. Just out of interest. No, okay. So I'm just going to exit again. Go back into Kicad. No, exit Kicad. So if you, by the way, if you add that directly, if you just went and added that directly to the library tables, it would be there. But now we can see that it is actually there. Now that it's got a unique nickname, it's there. So this is quite useful now to know. So you can go and edit the library tables there, or you can edit them in the project specific libraries. You can actually just edit the, this is all of our directories. You can just edit the fp-lib-table there. There's actually a couple of other places where the fp-lib-table is. One of them is in config Kicad fp-lib-table in your home directory, and this has got all of the main ones, and it's got all the GitHub URIs. There's also, I think, user local share Kicad template fp-lib-table, and I think that's the default one that's loaded by Kicad. That's kind of its own internal path. So it will look there and see if that is there, and then it's probably then added to by the one in the home directory, I would guess, and then added to the project with the project specific ones. I haven't investigated that further, like what order they're actually read or something like that, but you can see how you can add them, and that it's actually very straightforward. So in any case, now that it is in the library path, if I go back to the footprint editor, I can now set an active library. Tactile switch footprints is there, which means we're working on this footprint library now. And from that, I want to import that footprint from this library, show them all, and we've got that switch that we were creating. So now we're editing the switch. So what we want to do then, we need to create this layout. Now, one of the things we know that we'll have to look at the diameter here. Now these will be in millimeters, the way that you can find out, or they might be in inches. What I think is going on here is we've got millimeters and then inches in brackets. Usually on any diagram like this, it should say somewhere what the units are. I'm just trying to see if I can see it It's probably on here somewhere, but I know it's millimeters. Usually it will say it. Maybe sometimes they don't. You know, sometimes you get really crappy schematics, crappy, you know, diagrams, where it just doesn't even say, and or there'll be really useless, confusing layouts and things like that. But it seems like in the majority you can work out what you need to do from the document. We know it's a 6mm switch, so that 6 there is 6 square. We know that measurement is in millimeters, and so we can see here that the pins are 4.5 mil apart there. So it's kind of rectangular when looked at from the perspective of the pins. So, and it's 6mm wide. Now looking at this, there is a kind of a kink there, but that doesn't really matter, because as long as the hole is there, we can kind of push that through, push the kink through, and either fold it over or solder it and snip them off or whatever. And we don't really care about the height here in our case. And what we can also see here is that the width there, the horizontal width of these pins, is 0.7 mil, which means that we need a hole of like a mil or something. So let's just go ahead and try and create this layout. So what I think we want to do is we will probably want to put the holes, since that's the edge there, if we put the holes at 6 mil apart, the hole will be centered there, and then that's actually very, very narrow indeed. You know, that's probably 0.2, 0.15 mil or something. And if we've got a 1 mil wide hole, then that will easily be encompassed by it. So what you can do on here, I'm just going to close that away, because we know that it's 6 mil apart and 4.5 mil that way. Now in the footprint editor, you can, using this tool, you can draw silk screen. You know, you can make this any kind of crazy shape you want. Let's not do that. That's what you can have printed on the PCB. And you can also have pads, and it's pads what we want to add, and that's what's going to be exposed as copper. And we know that we need 4 holes. What you can do is select a grid, say a 1 mil grid, and we know that we want them at 6, according to our switch, we want it at 0 and 6 mil, right? Or -3 and 3. And because we've got that grid, we could, for example, let's just pretend it was at 4 mil up, then we could click on the pad and add a pad in there. But that's not quite in the right position, because we want a spacing of, oh no, I've closed that away. Sorry about that. Problem with doing a live demo. Right, stay there this time. We need a 4.5 mil spacing there. So what I typically do in this case is I will set up a custom grid, because then I know I can get it perfectly aligned. And what I want to do is, we're going to have it so that the grid is 3 mil spacing in the x-axis, so that there'll be exactly 1 point there and 1 point there. So if we go to dimensions, use a grid size, and this is where you can set up custom grids. So if we set the x to 3 mil, it's in millimeters there, you can set it to inches, and then we want 4.5 is the spacing here, but which means from the center line that pin is going to be 2.25 mils above. So if I set the Y grid like that, do that, and then choose that grid, right click, grid select, use a grid, you can actually see that those are in the right place now. They're actually at the corners of the 6mm, and they're at the center of those 2 points. So now what we want to do is add in the pads in those locations. So actually, just let me delete that. Let's edit the configuration of this pad for now. So in looking at the pad properties, we'll call this pad number 1. It's through hole circular, and we've got the drill properties over here. You can have a circular or an oval drill. We're going to have a circular drill. Now, given that it's 0.7mm wide, let's make this hole 1mm. But then the pad is not quite big enough because the pad was only 0.89, so we need that to be, let's say, 1.5. So now we've got a pad that has a 1mm hole, and it's got an aggregate of half a mil of copper around the outside exposed. So that should probably be okay. Now sometimes in these layouts, they actually suggest what the diameter of the drill hole should be. Okay, yeah, there's more. They'll suggest what the PCB layout should be. In this one, it doesn't look like they necessarily do, but it's quite convenient when you find a schematic where it shows you what the pad should be. Just let me give you an example of that so that it's clear what I'm talking about. If I was to look up something like probably a transistor. Let's have a look. Yeah, so this is just for a transistor. Yeah, here we are. So for this SOT 223 footprint, it actually has in the datasheet, it has an example of what soldering footprint you should use for this reflow. In this case, it's an SMD component, so there's no through holes. And you can see it shows you the diameter and the spacing. So it's quite easy to, once you've got your component, you can usually find out what the footprint has to be, and don't be scared of that. Anyway, back to editing our footprint. We've added that pad, and the reason I didn't add all the pads in to begin with is because it remembers the settings of the pad. So we now have all 4 pads for our switch. And that should be alright, because that is a 6mm gap between there. And there's a 4.5mm gap between there and there. So that matches this layout here. And because of the way that the pins are very thin on that side, sort of in that orientation, so they'll easily fit through a mil hole there. I mean, if you were really concerned about this, you could try and change it. For example, they are actually 6.5mm apart, the center line, according to that. So you could do it at 6.5. Maybe we should do it at 6.5 then, just to be sure, because then we know it's directly aligned there. Assuming that angle is actually, that they don't go out any further out. Okay, let's assume it's 6.5 then. So just let me delete this and I'll put this back in. What I'm going to do is change the grid again. So we want half of 6.5, so it'll be 6.25. Put them in. Now they've got the wrong numbers, so we want to change the pad numbers back. Now I happen to know that the way that this switch works is when you connect from these two pins are actually bridged and these two pins are bridged, and when you press the button down it will link that bridge with that bridge. Okay, now there is a problem here, which is that in our schematic we only have there's only two pins, you know, for the push button switch. We could put 4 pins on there if we wanted, but because maybe there's some circumstances where, you know, you're going to use all 4 of these pins, whereas really, I mean, in a way this switch is just like this because it needs 4 anchor points essentially. But this can be a little bit annoying because we've labelled the pins 1, 2, 3 and 4, these will be mapped to pins 1 and 2, and then there'll be 2 pins left where it doesn't know what to map them to. So the way we can address this, as I said, I know that this is effectively one contact and this is one contact. We'll actually name both of these top pads 1 and both of these bottom pads 2. So that's fine. You're allowed to do that. And then what will happen is when we import this into PCB new, it will say you've got to connect. This is called pin 1 and it's connected to VCC. Well, that's also called pin 1, so that has to be connected to VCC. That's called pin 1, that has to be connected to VCC. You can do that. You can have as many of the same name as you want. The only disadvantage here is that when we import this, well, you'll see. I'll show you. So we've done that now. Let's save it. Just do Control S, save over the old thing, go back to our PCB, and what we're going to do is change this footprint for the switch. So if I click Edit and click on Change Footprints, now of course we could do that in the association from here. We could go into the netlist, generate a netlist, run a CV-PCB and change the association. But we're not going to do that. We're going to do it from here. So we're going to edit click on Change Footprints, and at the moment it's pin headers, but let's browse. I'm going to change both of them, which means it will change both of these footprints that essentially have the same reference at the front. And I'm going to browse. It takes a while to load because I've got the GitHub footprints being loaded. I should really work out a way to download those and just have them local instead. Look up, what do we call it? Tactile shallow switch, and press OK. Change modules, pin header straight, tactile mod switch, yes. Now you can see that both the switch 1 and switch 2 have now been replaced by that footprint. And looking at this, you can see that both those pins, pin 1 need to be connected to VCC and pin 2 to pull high. So I just want to align them so that they're, you know, somewhere sensible. And that looks like it'll do. Okay, so that is how you create footprints. I mean, I don't really know what else to say. I guess you sometimes might have quite complicated footprints. You know, if we go back to this thing and look at that footprint again, I can close that away now. The spacing on this one is quite odd, but you can. I've not really found a problem. Just you sometimes need a calculator to work out differences and so on. But if you assume that's the origin, you can usually get by just changing the grid, the user-defined grid, so that you can get it in the right place. Or if you can't do that, you can usually always do that, but Sometimes it might be more convenient, like you know that something is near to this pin, there's one over here for example that is relative to that pin or in a strange position, and you don't want to change the grid. You could just, because you can change the X and Y positions actually just here, then like I could add an extra one in here for example, and if I knew it had an offset relative to there, I could just look at this, add on to this what the offset is, and just manually change the position there. So it's not it's not that straightforward to use. Well, it's very straightforward to use, but I mean it could be better. Like if it had a way to set for example offsets for pads and then move them relative to the center and things like that. I mean, if you look at this, it does actually have offsets, but the one problem I found with changing offsets is that it actually then moves the point at which the in PCB new at which copper traces will lock or snap to. Now, which is a little bit annoying because you need them to snap in order for a PCB new to believe that they're actually attached. If you don't care about PCB, you can still export a plot. You can still sort of manually take a trace, and as long as it was intersecting the copper there, it would be fine when you actually made the PCB. But you want to play along with PCB new and ensure that it says everything's fine. Alright, so that's the end of this tutorial, and in the next tutorial we're going to finish off this PCB, go through some sort of manufacturing ideas, manufacturing constraints and so on. Thank you for listening, I hope that was helpful. I've got a little bit of a cold, I'm just making up excuses.